Now we will see a case of multiplying the numbers with either 99,999, 99, or any other bigger number you can think of. So when these big numbers are coming into pictures. So how we are doing it is this is just by observing the pattern you will find out. So here you see the pattern that we have written here is 9 into 9. Result is 9/9 into 218. So what is the pattern here? The pattern is this side of the number is 1 less than this and this side of the number is 9's complement of this number 9's complement. When I say 5 9's complement of 5 is 95, that is 4, and 9th complement of 3 is 93, which is 6. That means in simple terms you can say how much it is less than 9. So this side of the number is 9th complement of this side of the number. Applying the same rule here, this number is 1 less than this number. True 21 is 1 and this number is 9's complement of this side number. That means 891 is 8. Again. Similarly, this number is 1 less than this number and this number. 7 is 9's complement of this number, that is 927. So similarly, any case you take, let's say take the case of this 9 into 7 is 63. This number is 1 less than 7. That is 716, and this number is 9th complement of this number. That is 963. So if you extend this to higher numbers also, you will always find the same result. So same kind of pattern you will observe. So here we have given two examples. You see here I am doing 9,999 into 7,858. Just think of Indiana a conventional way how much time it will take. But in this way it is like first thing is 1 less than this number. You find that is 7,857 and then find 9's complement of this number. That means subtract from 99999 minus 7 to 981,954,972. That's all. So answer is 7857214. To similarly think of this number. This number is quite big number. I have 12,345,679 with 56,432. So next step is just 1 less than this number, that is 56,431. And then if you see here the numbers are 12,345 numbers are this side, but here we have 1 2 3 4 5 6 7 numbers, right? So that means I need to put 2 zeros here, which I can write. Actually this number is 0056431 just to make it equivalent. So that when I subtract it from 9, this numbers come 9 to 0 as 9. So 9 to 0 is 9 again, 9 to 0 is 9. After that 9 to 5 is 4, 9 to 6 is 3, 9 to 5 is 9 to 4 is 5, 9 to 3 is 6, 9 minus 1 is 8. So this is completely a 9th complement. So that's all is the answer. Let's check out once. So we need to multiply 7 9s, 12,345,679 into 56,432. So our answer is 5 sextillion 643 quintillion 156 quadrillion 431 trillion 994 billion 356 million 843,568. So that's all. So that's all is the answer for us. So this technique has a limitation. The limitation goes like this. This formula holds good when the number of 9s in the multiplier are more than or equal to the digits in the multiplicand. That means in simple terms I cannot using this formula. I cannot say how much will be 99 into 353. I cannot say because here the number of digits are 3 here. And number of 9s are 2 here. But the other way is possible. That is the case here. We have 7 digits here and 5 digits here, which is possible. But this case is not possible. So I give it this case as one homework for you guys to find out, to observe the pattern first and then find out what is the common formula to achieve this. So that's all on this lecture. On the next lecture, we are going to cover something very interesting, which is finding the generic rule of multiplication. What is the generic rule through which we can multiply? So let's meet in the next session. Hello everyone. Welcome back to the session. So this session is going to cover some of the basic techniques using which we can multiply any numbers. There are no specific cases we can multiply any numbers. As you can see here we have told the method name as Erder-Tiriac method. Erder means up and Tiriac means crosswage. That means this method involves something related to up and crosswage action among the numbers. We will check that how this Erder-Tiriac name matches with the action that we are going to do with the numbers, and finally, how does it help us to do some multiplication. So to understand that, first let's look at this method in a graphical way first. So here you can see that we have drawn some points, set of 3 points in 2 different lines. So what we want to do with these points is I want to connect these points in every possible way, but we need to make sure that the points belongs to 2 different lines. So first thing that comes obviously to my mind is I can connect these 2 points. Next connects, I can connect these 2 points. I can connect all 3 points crosswise, then I can connect these 2 points, then I can connect these points. So if you see, this is just a symmetric way of this is symmetric to this and this is symmetric to this. And here we are connecting all 3 points. So if you look at this, then we can assemble all these things to one point. What is that figure? How will that look like? That look like this. So if we have 3 points like A, B, C and Def, what we have done in the first step is that if you take out the last figure, this is the first step we have done there. And this is step number 2. It has a different color coding, so you can know that I am connecting A to East and B to D, and the next point is that this is step number 3. I am connecting A to F, D to C and AMP D to East, sorry. And the next point is that I am connecting, this is 4th step, D to F and AMP E to C, and next point is C to F. So there are just 5 steps and we are connecting all numbers in all possible ways. So just keep this in mind. I hope this is not a confusion. You can just try out tracing 3 numbers and try to connect as many as you possible. Only make sure that you are not connecting the numbers in the same row. That means I don't want a line between A and E, B or B and AMP C or A and C. Similarly, I don't want line between D, E, F or DF. Just this would be in 2 different lines. So if you do that, you will end up with this pattern. So once we end up in this pattern, then we need to figure out how we are going to use this pattern. When we talk about Erder-Tiriac, you can now see that these are the different actions that we take, because either it is up and diagonal. So this is directly up A and AMP D, and we can say A and AMP E is up and diagonal. So that is why the name of this method is Erder-Tiriac. So we are done with knowing how to do, but exactly what to do. Using numbers. Let's check this out. So here there are numbers 345 and 876. What you can see now is a conventional way of doing things. Let's check out how I will do in a Vedic mathematics way, that is, applying Urdu-Dirac method. So the number goes like this: 3 to 4 and 5s 345 into 876. So here you can see when we start multiplication on the conventional way, we start multiplication from this side. But here I'll start multiplication from this side. 8/3 is 24. So if you remember, according to the figure, we have done just this. The next thing comes is I need to do this. So that is 37 yar 2184 yar 32, that means 2132, which is 53. Write it in this pattern. The next is we need to do 3 into 6, which is 18, plus 8 into 5, which is 4040, plus 18, which is 58, plus 7 for the 28, so that gives me 86. Next is 4 into 6 and 7 into 546 are 24, 7, 5 the 35. So if I make 24 plus 35, that gives me 59. Then next is 6/5, which is 30. That's it. Then you just add this off. This is 0. This is 2 over 1 carry forward. This is again 2 and 1 carry forward. This is again 21 carry forward 5410 because it's 10, and this is 2. So the answer is 30,220. That's all is the answer. In the initial stage it might look like very difficult because you have to do lot of additions. But going forward, once you practice this method and you have to multiply higher numbers, it's going to be really easy. I can show you one more demonstration using 4-digit numbers. So here we have multiplied 7,593 and 8,721. So what you can see is a conventional way. Let's try out in the very liquid. So the numbers are 7,593 and 8,721. So as we know that we will start the multiplication from this side only. So 7 to 8 is a 56. I just tried 56. Next is 7/7 yar 49 plus 8/5 yar 404049 is 89. I write 8 to 9. Next thing comes is this, taking three numbers all together. So 7 to the 14 plus 8 9 the 72 plus 7 5 the 35. That gives me 1/21. So while writing 121 I did not need to write 121 like 121. So next thing, taking three numbers. Next thing is taking four numbers like all multiplication, like 7 into 1, which is 783z 2452z 1097z 63. So adding all these numbers I get 104. So this is 104. So next again taking three numbers like 593 and 721, so 5 ones are 573 are 21/9 to the 18. So that gives me 44. Next thing is that two numbers 9 ones are 9/3 to the 6. So 9/6 is 15, right? 15 next is 3 into 1, which is 3. That's all. Now if I add all these numbers, I get 3 to 5. This is again 5, this is 8, this is 1. This is 9 to 11 plus 112 to 1. 6 8 plus 614 plus 15 plus 11,661 5 plus 1 6. So the answer is 66,218,553. So only thing you need to take care here is when you are doing the multiplication and then addition. You are not leaving anything behind, just make it a practice. It will be very easy for you going forward. Just do one thing when you are doing this. If at all the additions are bigger, then you can just scribble it in the side and try to do it. Let's say I am doing a multiplication of this step that is 7 into 2, which is 14. Write it down here: 7 into 2 plus 9 into 8, which is 72, plus 7 into 5, which is 35. So this addition is quite simple here. 5 2 plus 7 plus 1. 527 plus 41,111 carry 4 7 plus 310 plus 1 plus 111. So that's all. So I get it like this. So if you start practicing, you know all these things will come automatically to you, like adding 72 plus 14 plus 35 you will do mentally. So try to do it always in a without pen and paper, so that you develop this. Your brain gets developed of adding numbers. So this is not something very big thing. Adding 72 plus 35 plus 14 is not a big thing. It's just a matter of time of practice. So once you practice, you can all master this technique. So please try out the exercise that I'm attaching with this tutorial. It will really help you in refining your skills of multiplying, and hope this technique helps you. Thank you. Hello everyone. Welcome to this session. This session is all about knowing how the UDA-Dirac method works. As you can see, the formula is ax square bxc whole into dx square. xf gives me another algebraic expression. So this algebraic expression can be applied for 3-digit number multiplication. So this you can expand through a higher polynomial to get 4-digit number multiplication, 5-digit multiplication, and so on. But this is the basic thing, that if we can understand this, then other things are just follows as it is. So here the point to note here is the number of terms we are getting here starts from x to the power 4, because the highest power of x in the first polynomial is x squared, and the second polynomial is also x squared. So that's why the term starts from x4 and goes till something without having x, which is actually x to the power 0. So because we have terms here without x, or x to the power 0. So that's the principle here. Let's look at the multiplication point of view, that how that UDA theory of application coming into picture here. So I have just written the same thing but in a multiplicable way. Just like here. If you can see, this is ax square bxc, and below I have written dx square exf, and the same algebraic expression that the result is. Let's see how I should multiply to get this result. If you see, the first term is ad into x to the power 4. And how do I get ad is by multiplying a into d, and next term is a east plus bd into x to the power 3. How do I get ae is multiplying like this, and bd is multiplying like this. Similarly, to get the coefficient of x square, I multiply af that. You can see that afcd and b east. And similarly, to get the coefficient of 11, multiply b and amp, f and east and c, and to get the coefficient of x to the power 0, or without any term related to 11, multiply c into f. So if you can see here, actually to get this, all this coefficient, we are doing something that we have seen previously in a graphical way. So from this is where the graphical thing comes into picture. It's not that the graphical thing is that is why this comes into picture. It's not that the basic is this method since we are getting it like that. That is how the graphical method came into picture for easier understanding and practice. But why we are doing that order? This is the explanation. So let's take out one example to check that how we use this thing to end up in the multiplication technique that we have learned till time. So the number that we have multiplied in our example, let's take the same number so that we can check that as well. The numbers were 345 and 876. So to put this numbers into x square bxc format, I can write this 3 into n square, which is 104 10 to the power 15. Similarly, I can write 876 as 810 square plus 7 into 10 plus 6. So now this represents your x square bxc and this represents dx square xf, so the formula goes like this. After that we multiply 8 into 3. That gives me 24 into 10 to the power 4 plus 73s are 21, 84 the 32 into 10 to the power 3. To get coefficient of 10 square it is 3 into 618, 5 into 840, 4 into 728 whole into 10 square plus. To find coefficient of x it is 4 into 6 plus 7 into 5. I didn't do direct multiplication here into 10 plus 5 into 630. So now if you add all these numbers that will give me the result. That means this is 2440s, this is 5330s, this is 8620s, this term and this term is 59, 1030. You add all these things, you will get your result as whatever we got previously, that is 302,220. So this is the actual technique behind our Euler-Theoric method. So, I hope you clearly understood how this formula guides actually the Euler-Theoric method. We present the Euler-Theoric method in a graphical way, because it is easier to understand and practice. But the actual technique which guides Euler-Theoric method is this that we have just discussed. Now, hope you have understood all the concepts that we have discussed till now. Thank you.